Today we will be talking about non-deterministic finite automata. So far, all the finite automata that we have seen are deterministic. And let's make sure that we understand what we mean by deterministic. So who can give a precise definition of a deterministic versus non-deterministic? We won't understand non-deterministic without understanding what deterministic means.
We figure out how it works. That's how it works.
So I need more specific properties. That yes.
There's exactly one transition out of each state for every symbol.
Exactly. Yeah. So there is exactly. So this is a state for every state. There is exactly one transition per symbol. So if your alphabet is A, B, C, then you have a transition, exactly one transition for A, one transition for B, one transition for C, and this applies to every state. If there is one violation of this, it's not going to be a deterministic finite automata. It's going to be a non-deterministic finite automata. So what are the possible violations? The possible violations, so this is DFA. Possible violations are having multiple transitions for the same symbol, like A and then another A and another B. Sorry, I said another A, then I wrote a B. Okay. A, B, and C. So here, this is not a DFA. This is an NFA, non-deterministic. Now today, in fact, we will understand by example why this is non-deterministic. So right now it's just a definition. Just what we need to understand at this point is the definition. But to appreciate what this means, we have to go through an example and see why this will cause non-determinism. Well, in fact, it's clear here, right?
Yeah.
It's you have two options, right? So that's why we call it non-deterministic. You can either take this or that. So both of them are valid options. So now you have multiple options. So that's why it's non-deterministic. So in fact, non-deterministic means having multiple options. It doesn't mean random. So it's not deterministic versus random. It's not a random finite automaton. It's just you have multiple options. So this is one possible violation. Another possible violation of the DFA property is having something like this. There is a transition only for A, and there are no transitions for B or C. So this is also an NFA, not a DFA. Why would this work? We'll see an example. So when we see the example, we will know, why this can be useful, why this can be useful, and why the third violation that can happen, which is having epsilon transitions. So this is possible violation number 1, possible violation number 2 of the DFA property. Violation number 3 is having an epsilon transition. What does an epsilon transition mean? It means that you can transition from this state to this state without reading any symbol in the input string. Yes?
I don't understand how the second one is a non-deterministic finite automata.
Well, like I said, when we see the example, well, you have two options. For now, just...
No, not that one, the one below it.
Oh, this?
There's only one path going to A, just like it's a deterministic finite automata. I don't know why it's non-deterministic.
Okay. So I guess the answer is we'll see the example. We'll see why. It's just here, it's non-deterministic in the sense that it's not telling you what to do if there is a B. Right? So you're not told what to do if there is a B. So it's not saying what happens if you get a B or you get a C. It's only telling you what transition will take place if you get an A. Yes, another question.
What determines, as far as the second example for NFA, not the one with the single line, what determines which path on an option when A comes up that the...
We'll see that. So, like I said, right now, all what we need to understand is the definition. So we need to understand the definition of an NFA. How useful, does it make sense or not? This is what we will see when we go through the example. So don't worry about understanding at this point why this makes sense and why is this useful and all of that. We understand it when we go through an example. In fact, most of the lecture will be spent going in detail through an example tracing how an NFA can process a string. And this has an epsilon transition, so this has the option of transitioning from state Q1 to state Q2 without seeing any symbol in the input. Okay, now let's get to the example. Just for now, for a definition, just make sure that you understand this definition of an NFA. Okay, so let me now give you an example. The last example that we had last time was this. The language L, W such that W contains 101 as a substring. That was the last example that we did last time, right? Now, what if I change this language? What if I make it a little bit more complex by saying contains 101 or 11 as a substring? Okay. Now, with this language, if you try to construct a DFA for this, you'll see that it's going to be hard. But it's not impossible, as we'll see. But this is something that we can recognize with an NFA, or that we can construct an NFA for much more easily. Constructing an NFA for this is much easier than constructing a DFA. Why? Because for an NFA, and I'm gonna write or draw the transition diagram for the NFA, but then we'll spend the rest of the lecture, or a good part of the lecture, understanding how it works. So an NFA that recognizes this is like this. This is my start state. Then I have 1. If I get 1, I transition to Q1. If I get 0, I transition to Q2. If I get 1, I'm going to redraw it. It will stay the same, but I will just redraw it because I don't need much space here. I need more space for the next transition. And for this transition, I can say, if I get a 0 or an epsilon, I will go to this state. And then if I get a 1, I get to this state. And this is an accept state. And I will call this Q1, Q2, and this is Q3. Okay, so what I'm saying here is that, the transition, I will make forward progress towards accepting this string. If I get a 0 or an epsilon or nothing here, I can recognize the string if I get a 0 or nothing. And this is the substring. Before and after this substring that I'm looking for, I can have anything. And anything can be just, saying I can have anything before, anything after. You can just say this. 0, 1, 0, 1. So, anything, any string, which could be empty, non-empty, followed by 1, then 0 or nothing, then 1 will get you to an accept state. Now, how does this work? And why does this recognize the strings that belong to this language? So let's trace it on the following string. Trace it on 0, 1, 0, 1, 1. Trace it on this string. We'll see how the NFA works. So initially we are in Q0. initially we are in Q0. Then the first symbol is a 0. So now we look at this. We are in Q0 and we get a 0. What does it tell you?
Loop back on it.
Stay in Q0. So you only have one option. So on a 0, you just stay back in Q0. So you have one option. So far, it's like a DFA. Now, next you will get a 1. Now, we are in Q0, and we are getting a 1. Now, how many options do we have? 2. We have 2 options. So the first option is going to Q0. The second option is Q1. In fact, there is a third option. And what's the third option? Does anyone see the third option that we have? Okay, think about the epsilon transition. Epsilon transition means you can transition on nothing.
Nothing.
Yeah, you can transition even if you get nothing. So here, the 1 takes you from Q0 to Q1. But then this tells you, you can go to Q2 if you get a 0, or if you can choose to go to Q2 if you get nothing. Okay? So this means that you can always go from Q1 to Q2. You always have the option of going from Q1 to Q2 without getting anything, without reading any symbol from the input string. So I have 3 options. Option number 1, staying in Q0. Option number 2, going from Q0 to Q1. Option number 3 is going from Q0 to Q1, then continuing along this epsilon or null transition to Q2. This is a key idea. Does anyone have any question about this idea, about the 3 options that we have? So far, how many symbols have we processed?
2.
We have processed only 2 symbols, 0 and 1. See, with the, even though we had 2 symbols, we managed to get to Q2 because of this epsilon transition. And if we had an epsilon transition to Q4, then we would have had the option of going to Q4 as well. So we would have had the option of going to Q4 if we had an epsilon transition from Q2 to Q4, or a null transition. Okay, any questions? Oh, so let's get rid of this. Now, what will happen next? What will happen next is I get a 0. Now, I have 3 different possibilities, 3 different paths. That's why it's non-deterministic. I have 3 different paths. And I have to process the 0 for each possible state that I can be in. So what this means is that at this point, after reading a 0 and a 1, I can be in any one of these 3 states. So you can think of this as a compound state that I'm currently in. This is a compound state that consists of Q0, Q1, Q2. So after reading a 0 and a 1, you can be in any one of these 3 states, and you can think of this as a compound state, which consists of Q0, Q1, Q2. Yes, question?
So I was having a question about Q2. So if it takes a 0 or a 1, it can either go to 0 or 1. But why can't it go to Q2? Because wouldn't it have to
Okay,
connect
which
from...
transition are you asking? When we are we in Q1 or in Q2?
So this is from before when we were inputting a 1. So if you input a 1, it can stay in either Q0 or it can go to Q1. How can it go to Q2? Because wouldn't it have to go to Q1 first and then have a 0 or a epsilon to go to Q2?
Yeah, it will go to Q2 through Q1. But where will it end up? It will end up in Q2. So yeah, there is no way of getting from Q0 to Q2 directly. It got to Q2 through Q1.
That was my
So
question.
the one took you from Q0 to Q1. Then after you got to Q1, you have two options: either staying in Q1 or transitioning to Q2. You know, it's like it's like a free transition. You can transition from Q1 to Q2 for free without getting any symbol. Yes.
On the transition in Q1, what happens if you have the symbol 1, and same thing on Q2, what happens if you have the symbol 0?
Okay, if you had 1 here,
Yeah. Is it also transition to Q2? Oh,
if you had like this,
yeah.
okay. So now with what we have, when you are in Q1, you can go to Q2. If you see, if you get an epsilon, a 0, or a 1, yeah, but this will not affect the transitions that we made so far, because you have to get a second one. You can't do it with this one. So we have already processed this one. So you can go from Q1 to Q2 if you get a second one, right? Not this, but not the first one, not this. But you have to get another one in order to go to Q2. Yes?
So removing the epsilon and leaving it as it is with the red ink would take away the Q2.
Okay. Removing the epsilon and
And that's it, would remove the Q2 from the diagram on the right.
on which transition?
All the way to the right. More.
Oh, the right?
Oh, sorry.
The other example.
I don't know how to say it. It's a
Okay,
diagram, right?
so you want this 0 and 1?
Yeah, and then it would remove the Q2 from the 0, 1.
Yeah, so in this case, I will have to remove the Q2. Because there is no way of getting from Q0 to Q2 with only 1, 1. You will need 2 1s to get from Q0 to Q2. Okay? Okay, so let's go back to the epsilon. Now we will have to trace this thing for all 3 possibilities. So now, if we are in Q0 and we get a 0, so Q0 and you get a 0, how many options do you have? One option, you only go to Q0. If you are in Q1 and you get a 0, where do you go?
Q2.
To Q2, and that's the only option that you have. If you are in Q2 and you get a 0, what does this tell you?
Nothing.
Yeah, nothing is like go nowhere, and there is no transition, so you have reached a dead end. It's like a dead end. So this means that with a 0, this is going to dead end. What it means is that you don't have any transition. Having no transition is equivalent to having a transition to a trap state in the DFA. So it's like here, implicitly you are having a 0 transition to a trap state. Okay. Right? You will get trapped in the trap state. So it's like, the NFA is not telling you where to go if you get a 0 here. Right? So you're saying, okay, NFA, where should I go if I get a 0? And it's not saying anything. So not saying anything, it's like saying go to hell. And go to a trap state. Yeah.
If there was another transition from Q0 to Q2, like a 1, would you also list Q2 again in the previous step?
Q0? No, we don't care about Q0 now. Okay.
If we go back a step and we added another transition to another state that we already listed, do we list it again?
Mm-hmm. Yes.
Oh.
Yeah. So if you, there's nothing that will prevent you from listing the state multiple times. So we already have, Q2 listed multiple times and Q0.
On the same step, though.
On the same step?
Yeah.
It doesn't matter. So it's like, this is a set of states. Oh, so you are saying that, I see. Now you're saying that if I had this, Q0 on a 0 takes me to Q2,
Yeah.
right? And then, should I put another Q2 or not?
Yeah.
The answer is, it doesn't matter. It's, this is not, what we are drawing here is not an NFA or a DFA. What we are drawing here is just a diagram to trace and understand this. So this is something that just illustrates what happens. Okay? This is not a DFA or an NFA, so there are no rules for this. This is just an illustration. And having two Q2s here, it's just like like a set with duplicates, and normally in a set you don't put the duplicates, so it's just, this is redundant basically. You can think of this as redundant, okay? So you don't have to put it again. So all what it means is that you can be in one of these two states. Yeah.
So if you're in a dead end, you just stop, you don't even wait for the next number to show up?
Yes,
It doesn't-
so you stop, but it's only one of 3 paths that reach the dead end.
So-
We have so far from Q0 with these 3 symbols, we have 3 different paths. 2 of them are good, and 1 of them dead-ended. So 1 of them reached a dead end. So if this had been the only path, then this string would have been rejected. The decision for this string would have been a reject if this had been the only path. But we have multiple paths. So this is a good question, because in an NFA, it suffices to have only one good path that gets you to an accept state. So in an NFA, a string is accepted if there is at least one path that takes you from start state to accept state. So let me write it down. Let me write this down. So in an NFA, a string is accepted if there exists at least one path, at least from one path from the start state to an accept state. Okay? Oh, so 2 paths are good so far. 1 path is bad. 1 path led to a dead end. Now we will continue. Now we have 0, 1, 0. Now we will get a 1. And we'll have to trace it for both options, the Q0 and the Q2. Now if I am in Q2, in Q0, and I get a 0, I get a 1. Now we are done with this, and now we are here. Q0 and I get a 1, it takes me to
Q0.
Q0, Q1, or Q2. Same thing repeats. So whenever there is a 1, Q0 splits, or it branches, 3 different branches, Q0, Q1, and Q2. Okay? Now what will happen if I am in Q2 and I get a 1?
You got Q3.
If I'm in Q2 and I get a 1, there is only one possibility, which is going to Q3. And Q3 doesn't have any epsilon transitions out of it, so you must stay there. So keep this in mind. If a state doesn't have any epsilon transition out of it, you must stay in it. If it has an epsilon transition out of it, you will have the option of proceeding to the next state. Okay, so now Q3. Now, does this tell me that this string, the string that I processed so far, 0101, accept or reject?
Accept.
Why is it an accept?
This is 101. You're in Q3.
Because there is a Q3 here. There is an accept state. So Q3 is an accept state. So my current composite state at this point is Q0, Q1, Q2, Q3. So with these 4 symbols, I can be in any one of these 4 states. But one of the paths is leading to an accept state. So this string should be accepted. 0101 should be accepted. Okay? Now let's continue. Our string doesn't end here. Our string ends here. So let's just make one more symbol, which is the 1. Q0 on a 1, again you will go to Q0, Q1, Q2, and Q1, and you get a 1.
Nothing. Ends.
Dead end. You know, it's okay if some paths dead end. I only need one good path that takes me to an accept state. And you are in Q2 and you get a 1. This takes you to Q3, which is an accept state. And if you are in 3 and you get a 1,
You go to Q3.
you go to Q3. So again, this tells you that the string 01011 is also accepted. It also belongs to the language. So this is what the NFA is. This is how it works. In fact, tracing this, I just wanted to trace this to make sure that everyone fully understands how the NFA works. But we're not going to trace the NFA like this whenever we write an NFA. In fact, once we get used to it, we will find it easier than the DFA. We will find using an NFA easier than using a DFA to recognize a language. And it should be easier because you have more flexibility. So, being a DFA, the DFA is more restrictive. The NFA is less restrictive. It gives you more flexibility. So it gives you the option of having multiple transitions for the same symbol, or not having a transition at all for a symbol, or having an epsilon transition. So these are all options that you have when you write an NFA, but you don't have to take these options. That's why a DFA is a valid NFA. But the opposite is not true. So every DFA is a valid NFA. So to be an NFA, the DFA is the restrictive one. So to be an NFA, it's less restrictive. So every DFA is a valid NFA, but the opposite is not true. Okay. Questions on this?